the entrance here. Kitchen space here. And storage room here. Bathroom. Playroom, which is this room here.
Yeah.
Move around this side. Oh, no, not yet. So that's the office room, this middle section.
Yeah. Is there any light in there?
I don't think I've made that in there. So, yeah.
Oh, that's nice.
So one of the features was, if you know, no, that's too far back. So I wanted to make a big window on this side,
Yeah.
so that the light provide a massive light source later on in the day, early in the morning as well, and it's south facing.
Yeah.
And obviously the solar panels will be directed this way as well.
Yeah.
On the build. And this area was ideally going to be blocked off, and there'd be roof windows, so the light provided to the bottom floor would be from basically that big window.
Yeah.
And I'll ask you more about that obviously later.
What software are you doing this in?
SketchUp.
Right.
Yeah.
And the animation in SketchUp too, is it?
Yeah.
Yeah, fantastic.
Does building a home inside the mass of land pose any dangers to the user, to the home or to the home structure?
Yeah, it's very difficult building into the ground, and that there's always in any situation where you're building into the ground, there's always going to be some sort of water pressure building up. There's a sort of water table somewhere. There's a lot of water in the ground, so the challenge is always about firstly making sure that you can stop any water getting in. So you need some sort of tanking to stop water getting into the building, but also making sure you've got enough ventilation, because when you're building into the ground you obviously can't ventilate on that side of the building. So those are the main challenges that you have when you're building into the ground. Yeah.
Is the concept and function of this practical, and will it need, what thought will need to be considered in order to take it further?
Yeah, I mean, it's a great idea building into the ground. It has, there's lots of benefits in that you've got a much more stable air temperature further you get underground, so that the building will tend to stay cooler in the summer and stay warmer in the winter from being built into the hillside, into the ground in some way. The difficulty is that in order to benefit from the thermal mass of the ground, the sort of interior of the building needs to be kind of connected with that thermal mass. So, traditionally in kind of caves, or, in France, there's lots of historic kind of troglodyte dwellings where people used to build houses into the cliff. It has that benefit of staying warm in the winter and cold in the summer. The problem is the temperature that the ground is somewhere around 10 degrees, whereas in a normal living space you probably want to be more like 19 or 20 degrees. And the difficulty is that if you introduce insulation to keep the warmth in, then you're losing the benefits of the thermal mass that comes with the ground. So there's a sort of balance to be struck between benefiting from that thermal mass, but also kind of insulating the interior from it. So it's not easy.
Okay. Right. Are there any issues involved in building a home from modular panels?
It's quite a common way of building things now, using modular panels to put things together. One of the challenges is that everything needs to be very accurate before you start. I think builders typically like to work on things where there's a bit more flexibility and you can adjust things on site. If you make things in a modular way and they come to site and there's problems, it's much more difficult to change them. Whereas if you're building with bricks or blocks or just bits of wood on site, then making adjustments is easier. If you're bringing modular panels together, it happens very quickly, but you've got to ensure that they're very accurate in the first place.
Are there like many ways of preventing this lack of ventilation? Not lack of ventilation. I can see how that could be prevented, but also the water pressure from the soil.
Yeah, ventilation you can deal with mechanically is one way to deal with it. So with a passive house that I could talk to you, show you examples of. You have a mechanical ventilation system where you duct air around, you bring it in one side and let it out the other, and that's ducted, and that's one way of dealing with the ventilation problems you have underground. In terms of the water, it just needs careful detailing. There's normal, people build basements all over the place. It's a kind of normal thing to do. It just needs to be very carefully detailed to make sure there's continuous waterproofing in the right places that's not going to let the water through.
Is it the case of a vapor control layer, or is it more concrete?
Yeah, vapor control is a slightly different issue. So the challenge with putting a vapor control layer, vapor control is what happens on the inside of a wall construction to prevent moisture from the air getting into the insulation. I think between the inside and the outside of any piece of wall, if it's cold outside and it's warm inside the house, there's what we call a thermal gradient, so it might be 20 degrees inside and 0 degrees outside. And at some point across that wall, any water vapour that's in the air is going to condense into water droplets, and if that happens in the middle of the wall, and it's a timber wall, you're going to start to get mould growing in that position and rot developing. So a vapour barrier happens on the inside of a wall to stop water vapour getting into the wall. I think the situation up against the ground is a slightly different one, where you're trying to stop water getting into the house, which is a slightly different issue. So there needs to be a membrane to stop that water coming in, and that's probably usually going to be on the outside of the building, but sometimes if it's a concrete wall, you can have that on the inside of the building too.
So I'm wondering, because it's cob, and cob is based upon soil on the ground, I'm wondering how much more we'll need to add to that for it to be able to cope with that soil moisture.
Yeah, you need to make sure that there is, in that situation, you need to make sure there's a sort of membrane on the outside of the construction, and you need to make sure there's somewhere for the water to go that comes up against that wall from the outside, and you need to have a sort of drainage mechanism somewhere to take the water away.
Okay, so do you think that this design will reduce the social disengagement between families with the way it's shaped and the way the balcony sits across it?
Yeah, well, it certainly opens it up. I guess, certainly it allows people to kind of connect with one another. Obviously, the danger is that they start to kind of annoy each other with noise. If somebody's playing the TV really loudly downstairs and that noise spreads upstairs, that could be a challenge. But it certainly seems like quite an interesting model for housing to me.
How much faith did you have in this idea, honestly, regarding its possibilities for it to be used in mass in the future?
I think the idea of having panel construction is a really good thing. I think a lot of the construction industry is looking at ways to adopt prefabrication of things that are easy to assemble on site. So I think that's got to be a good idea. I think the idea of allowing people to get involved with making the houses, whether it's sort of self-build, custom build, or using people to sort of develop their skills on things is a good thing. And that's again something that is an issue across the construction industry that people are trying to go with. I think that works very well. The idea of communal living, I think, is quite an interesting one. There's a whole movement called the co-housing movement that's built around the idea of people building their own homes in clusters next to each other and sharing some spaces. So again, that's I think a very good idea. I think there's lots of good ideas in here. Yeah.
What factors should I alter in my design when moving to countries, maybe poorer countries, that have fewer materials?
I think each country has got different climatic conditions. So the construction that you have on the outside of a building in somewhere that's I mean, in the UK, the energy that you use in a building is all to do with heating the building generally. Whereas if you go to a different climate, a Mediterranean climate, tropical climate, there's much less requirement for heating, and it might be that the emphasis needs to be more on keeping the building cool, or it might sort of shift. So the likelihood is that the build-up of that wall that you've shown might be slightly different depending on what the sort of location is in different countries. Obviously, simplicity is quite important. I think cob is a very good material that's kind of available everywhere, and I think that's the sort of benefit that you've got here, is that's the sort of technology that can work, you know, in most locations to some degree, because it's a kind of, you know, you're just building out the earth effectively, and I think that's got to be a good thing that is very transferable, definitely.
When testing my product on a larger scale, in order to get primary research from families, because that's our target market, what would be a reasonable price to pay them to come in and for us to receive feedback from them, or either them or professionals?
In what way? Sorry, are you in a sort of prototype of the house you're talking about?
Like finding information about what people need, what people want.
I don't know. It's very difficult. You know, how you get decent research without actually building something. Okay. I think once you've built a house and you know that's one of the things you'd aim to do, is to sort of test out. You know, is to follow up once you've built something, once somebody's living in it, to try and follow up and sort of understand how it works. But it's much more difficult in the construction industry. With in the car industry, you know, you make a prototype of a car and you test it lots of ways, and you'll change it and you'll develop it and you'll test it again. Okay. In the construction industry, you don't really get the opportunity to do that very much. You kind of build something and you hope it works, and you put as much knowledge as you can in, and then I guess you follow that up and you try and gauge, you know, how well it's performing in terms of energy use, what feedback you can get from the users, but actually it's not until you then build another set of buildings somewhere else that you get to learn from that and take on board all of that feedback you're getting. Okay. I think the models are great, really, really lovely bits of work. I think what this model of the piece of the wall we've got here, I think it's really interesting to see all the layers on it, and that's really good. What you need to show is the studs that are holding it together, because where you've got insulation here, what you'll have is vertical bits of timber that happen, you know, typically every 60 centimetres apart. And there you then screw into those, and that's what holds the whole thing together. So if you had those, the whole thing would stay together much more securely, stably, and it also sort of shows actually what the construction of the thing is. So I think that's something to bear in mind.
Okay, that's good. And like looking at this model, have you got any comments about its arrangement of space? Or
I think there's lots of stuff that I really love about the model. I love the way you've made the model. I love the structure of the floor. In fact, I've got all of that exposed. Obviously, the ceiling height you've shown, it's like you've kind of exploded the model, which is kind of really helpful to see how it all goes. But it might be you just want to lower that so that it sits on that, so you can understand spatially how it works.
And the arrangement of spaces, someone said in college that where do you eat? So this is the kitchen area, and I thought I need to move maybe a living. This is my eating space. So I thought it might be best to move that in here or in this open area here.
Yeah.
And another function that I wanted to include was have this space like a free room to each room you want to go, sort of a central point. So there's 1, 2, 3, 4, 5 potential routes from that one pivot point, which is something that I wanted to create. Yeah.
I think that's great. It's fantastic. Yeah, as I say, if you lowered that whole top floor onto that, you'd have a truer sense of, you know, how high the spaces are and how it all work together. But it would also then allow you to possibly start mapping out this big window that you've shown here. Yeah.
Okay. Okay, I think that's good for this one.
Great.
Thanks.